Bat Machine. How you doing, guys?
Doing well.
So I got Bruce and Daryl here from Bat Machine. We're going to talk about Bat Machine and what you guys do and how it all started and all the good stuff and where it's going, mainly.
Oh. Well, thanks for having us.
Heard of good old Eric for a long time.
Oh, well,
but
thank you.
Never talked to you.
Oh, well, thank you. So, Bat Machine, how did it get started?
Well, it got started because my mom wouldn't let my dad buy me a 22. So, what's a kid to do? You just start making your own guns.
Yeah. Why not? All right, you're gonna have to elaborate on that a little more. That sounds like an interesting story. Number one, how old was this kid?
Probably around 14, I believe. I don't know, Daryl. Do you remember how old I was?
I don't.
You probably weren't paying. You probably weren't paying.
Yeah. Your first one would have been junior high. Functional.
Yeah.
I mean, we built the one that killed robins before that, but that only had a copper pipe and a nail for a trigger. But the neighbor was worried that we were killing robins with it.
Yeah. So always, my dad's a very mechanical person. Not only mechanical, but also electronics, whatever. So we've pretty much always been exposed to fixing stuff, making stuff. And from a young age, I always had an interest in firearms. I don't know how old I was when I started making knives, but made quite a few knives, folding knives, etc. And then, like I say, we had BB guns, but Mom wasn't really excited about us having a 22. So I don't know. I can't believe the project wasn't shut down by Dad or Mom, but Dad didn't have any machine tools. He had a rinky-dink drill press thing, that you mount your drill in a press and your hand drill. So between that and a lot of hacksaw and filing, I made a break open shotgun style pistol. And I managed to order a barrel liner from Brownells and drilled out a hunk of steel. It was kind of a monster, pretty ugly. Eventually I turned it into a rifle, but, so then when I got to high school, they actually had a machine shop. And so then I was like, oh, I know what I'm doing for the rest of my life.
Yeah. So this 22 that you made, do you still have it? Is it long gone?
I don't have that one. I have the second one I made in high school. And basically same design, but done with machine tools instead of hacksaw and file.
Okay.
The first one was pretty exciting to shoot. You made
can imagine.
Sure you had it pointed in the correct direction before you close that thing up.
Wow. Yeah, sounds like it. Now, who's the older brother?
I am.
Okay. So you had to take younger brother along for a ride, and did you make younger brother shoot it first?
No. Yeah, so Daryl's the middle brother. He's 3 years younger than I, and then we have our youngest brother is 9 years younger than I. And the poor guys, they had terrible influence from me. They all ended up in machining or engineering. So
it's not too bad.
It's treated me well.
Yeah, so that's interesting. So you built the 22, and then you built, with hacksaws and drills and hammers and such. Then you're actually exposed to machine shop, which then you turned the same design and made it just better with the use of proper tools. At what point? I mean, did you only make one, or did you make multiples?
Okay, by the time I got out of high school, I had made 4 bolt actions receivers. The only hiccup in the whole situation is that they wouldn't let me fit the barrels at school. So I was saving money for a new dirt bike, so I ended up buying a South Bend lathe to put in Dad's basement, and did put the barrels on at home. And of course, I always did my own stock work, etc. And then Daryl, you built at least one or two when you got into high school machine shop.
In fact, it's in the safe right here. But yeah. Again, this teacher, I went to a skill center for 3 hours a day for my junior and senior year. And the instructor machine shop, allowed me to build that was a bolt action as well, based on Bruce's design, including the trigger, but just couldn't have all the pieces together at one time at the shop or at the school.
Yeah. That's cool. I wonder if, I don't think that would be allowed nowadays.
Oh, no.
I think no way.
You think?
There's no way.
So the rest of that story is, okay, so my sophomore year, we actually had an instructor that was a machinist, but he decided to go back into machining instead of herding teenagers, because in high school, a lot of the kids that were in shop class in those years were there to get an easy class, and they really didn't care. They weren't there to learn. So I think he just got fed up with it. So the next year's teacher was a retired wood shop teacher that knew nothing about machining. And he lasted 1 year. And then they hired this other guy from England that he had such an English accent that we could hardly understand the poor guy. And he knew nothing about machining. So at that point, all my machining was I learned a little bit that first year, obviously, but you can't, one class a day, you don't learn that much in a high school setting, because he's got all the other kids to deal with. But luckily, the auto shop teacher was just in the next bay over. He had been a machinist. So if I really got stuck on something, I could go bug him and he'd help me out. But yeah, so there's a lot of self-taught stuff. You learn stuff that way for sure, but it wasn't until I got into trade school after high school that you learned all those things. Like, man, I wish I'd have known that before.
Yeah.
And then of course I had started during those years also worked for two different shops at the same time, and there's no substitute for working with experienced machinists and tool makers. That's for sure. The one guy I learned probably more from in the year I worked in that shop than I probably learned at any other individual job I worked at. A couple of very talented guys I got to work with in that shop. An old German tool maker, and another guy that his philosophy to machinists is you shouldn't work at a shop longer than a year. He said, you need to move around. He said, you're not working here after you finish trade school. He says, you need experience. You got to go to different shops. That's good advice. Not necessarily I didn't follow that, but I get his point. You do learn a lot when you get to work with a variety of people.
Right. You get exposed to a bunch of different techniques and skill sets. Now, I'm sitting here curious how you this bolt action, was it like a Remington 700 design, or what did it look like? So obviously trying to work with what I had available to me. And so it was more like I would say I'd never heard of Allen Hall in high school, but it basically is a Weatherby / Allen Hall design. In other words, a full diameter bolt type receiver with two locking lugs. Yeah, because the Remington 700, you kind of need a broach and
we did have a shaper, but I didn't have the skills in high school to know how to build cutting tools that I could broach a set of shape a set of raceways.
Yeah. Well, that's interesting. So you
during high school.
Yeah, go ahead.
During high school, he also built a mill.
Oh.
And he wasn't done by the time he graduated, so the teacher gave him keys to the shop, and he finished it over the summer. So.
Well, I built a barbecue pit, so I guess we're the same.
I look back at that and there is no way that would happen today. It wasn't the high school, it wasn't the shop teacher, it was the vice principal of school that gave me the keys, Daryl.
Okay.
To the shop. And working unsupervised. There was nobody there. I was there by myself. You think that would happen today?
No, not even.
It's like, what a different world.
Number one, nobody's going to even consider building their own mill, and I assume this mill was because of your gun builds that you decided you needed a mill. Yeah.
So have you ever seen those little closing mills?
Yes.
We had a closing mill and the Cincinnati number 2 horizontal was our 2 mills in the shop in high school. So I used the number 2 horizontal to build a slightly larger closing style mill. Knee mill it didn't have a quill, but, table trowel and stuff. And, I didn't know anything about scraping. I didn't know anything. I mean, I did my best as far as alignment and squareness and whatever. And it was usable. But, yeah.
That's interesting. We're talking about the lathe that you have in the background. You were telling me you rebuilt that lathe?
It wasn't, I didn't intend to. I thought it was in better shape than it was, but when you start getting into it, you realize that there's more wear in places. So yeah, I reground, I set up, and the Kumas, the LSs use a LeBlanc style forward way that's, instead of being a V like this, it's like that. Mm-hmm. And so this inner guide surface gets a lot more wear. Like a V-type way, they tend to wear straight down. They maybe have a little more wear on the inner, but for whatever reason, I don't know if it's oiling or what, but this way gets a lot more wear. And so basically the thing is, going to be cutting at a taper and anything long. So I set up, the top of the way had only like maybe 1,000ths wear over the 50 inches, but that taper was going to drive me nuts. So I set up a grinding, I don't know what you want to say.
Just like a rail?
Show you a picture of what it did. Well, see, the other thing, the Kumas, the LS series, the tailstock rides on rollers. So when you release the tailstock clamp, it lifts up about, depending on how they're set, 1 thou to 2 thou. And so it rides on rollers. So the tailstock ways get almost no wear on them. So basically I re-scraped the carriage tailstock shoe back into perfect fit. And then I built I took a tool and cutter grinding spindle and built a carrier to clamp onto the tailstock base and use the tailstock base riding on the tailstock ways to regrind the inside of that way.
Oh.
And then of course had to add the material back in that you've removed. So you mill the carriage out and use turkite or Mowgli's. I ended up using Mowgli's. And the tailstock bore on this one was really wore out, so I ended up rebuilding it with Mowgli's. Just went through everything. It's alignment wise, it's like a new lathe now. I really like my Akumas.
Probably better than the new lathe, huh? Just
what's that?
So probably better than a new lathe, because the new lathe, Speedy always says assume everything's broken until you check it. So if you were to buy a new lathe, you'd have to check it. At least this one's already been checked and corrected.
Yeah. There are some good new lathes out there, but they're not built to the same standard as the Japanese built during the 60s.
Let's say somebody wants to buy a gunsmithing lathe. What would you recommend?
Well, my idea of a gunsmithing lathe is a little heavier duty than most people's.
Well, let's go with that first, and then possibly something else that they should look at.
So we had, before I switched the shop's lathes over to Japanese manual lathes, we had, I had a Hindi for years, a number 2 Hindi. Had it for about 20 years, bought right out of high school. That was my 3rd or 4th lathe by that point. and a 16 by 42. I wouldn't recommend buying an old used machine for a guy just getting started in gunsmithing, because to do decent work, you do need decent equipment, especially when you're trying to learn. You don't want to be fighting a machine too. But I sold the Handy when I needed a larger spindle when we started building 50 BMG actions and needed to be able to chamber those for testing, and ended up with a Kingston Taiwan-made machine. And I was really impressed with it. The quality of the machine was good, and the range of speeds and thread ranges, metric and English, with no gear changes on the back end. And so we ended up with 2 of those. And then recently, Unknown Munitions over here in Post Falls, they were wanting to get a better machine, and I recommended that they look at the Kingston, and they ended up buying one. And I went over and checked the thing out new, and it was perfect in every respect. The Kingston is a really nice Taiwan lathe. I know a lot of people look at those Precision Matthews and Grizzlies, and I'm sure they're okay, but I've never personally ran one or checked one out. But I like a machine, a minimum of like a 1440, prefer like a 16-inch by 40 size machine for doing gun work. But you just get a lot more machine as far as rigidity, and they're generally built, I think, to a little higher standard when you start getting into a lathe that's actually might get used in a real shop instead of gunsmithing or hobby work.
When I was looking for a lathe, I just started looking around, and I found a used Webb. Are you familiar with Webb?
Yep, I've owned a Webb. We had a Webb in the shop for a while.
Yeah, it was a 1430. I wish it was a 40, but I thought, man, this would be fine. And I bought that machine. It's been such a good machine to me. That's what I chamber my
the Webb.
It is an incredible machine. I bought it for $2,500, and I thought that was just a pile of money. And nowadays, but I had no money, so $2,500 was a lot. But I still own that machine. I love that manual lathe.
Yeah, actually, the guys in the shop kind of wanted to shoot me when I sold the Webb, because they really liked running it. I mean, not that we do a lot of manual machining, but when they wanted to use one, they liked using that one. It was set up for gun drilling originally, is what I had that thing set up for, gun drill and receiver bodies. And then we bought a Haas TL2 that's all it does is gun drill and receiver bodies. Now we wire everything, but the Webbs, the Victors, the Cadillacs, the Huachians, they're basically all copies of Morisikis.
Right. Yeah. That's like saying, that's my manual lathe, and I'm super happy. The guy that was teaching me at the time, he had like a jet or something. And he said, Ronnie, he said, well, go find your lathe. And I looked around and I found that one. He's like, I am so jealous that you found that lathe. That is like the dream lathe for gunsmithing, because it's really heavy. It's about 2,500 pounds.
Yep.
He goes, It's super rigid, and it's, the headstock's not massively large. Anyway, I'm super happy with that thing. It's served me well.
Talking about rigidity, that's probably the biggest downfall to a lot of the quote unquote gunsmithing lathes that people are buying. They're sitting on cheap metal frames, and they just move.
What he did to his, that because it's all sheet metal, right, on the bottom. It has like a tray for tools and such. He actually poured concrete in there to weigh it down, and it helped. But yeah, he's like, I'd rather have concrete than the tools in there. And but it's like you said, rigidity, and it's really the biggest thing that these machines lack. The new ones.
Now, you're talking about a smaller machine. This is my first. I don't know if you can see that.
Yeah, we can see.
What am I looking at here? Yeah, the first Akuma I picked up. This is an LK version. It's a 14 by, I think this is 24. Kind of a short little bugger. But this thing weighs over 3,000 pounds.
Yeah. They're heavy. Like I said, my web is pretty short, but it's all cast, the whole thing, you know.
Yep.
Super heavy.
Same on that one. Cast.
Mine has actually a
a
dual horsepower feature. It's got a switch, you know, the motor's either 3 horsepower or 5. I never use it on 5 horsepower, but it's a pretty neat little deal. Sometimes every now and then when I'm turning something and as it's running, I play around with it because, you know, you get different speeds if you go to 5 horsepower versus 3.
Right. Yeah.
But, you know, for gunsmithing, 3 horsepower is more than plenty, but it's very capable. I mean, we've turned, ironically, when I bought my CNC machines, we made a lot of parts, you know, tool holders and such on my manual lathe.
Oh, yeah.
Just before we could start using the CNC machine.
Yeah. Yeah. Well, that's the thing. I mean, the CNC machines are where you make your money, right? And if you're doing any kind of manufacturing, it's just not practical to do much of anything on a manual machine as far as manufacturing. But they're kind of vital support equipment. You got to have one.
Yeah, for sure. So I assume I assume your middle name starts with an A?
It does.
Okay. So that's kind of what I figured. So that's where the name came from.
Yep. And then I have a cousin that's he's kind of artistic, and he's like, you got to do something with that name. He said, let me do you a logo. So he's the one that came up with the logo way back in, I don't know.
It used to look more
95.
like that, what his artwork was.
Oh, okay. So at what point do you decide I'm going to start making actions?
I never quit after high school. But I think I made quite a few falling blocks. I built the bolt guns, and then I got interested in falling blocks. So I made, I think, 3 iterations of falling blocks. And then around 1990 or 89, I think I made the 3rd version, and it was actually kind of had most of the bugs worked out of it. And I ended up making, I probably made about 15 of those, and sold a dozen of them as complete rifles that I built for people. And one of the guys I sold one of the first ones to is a local guy here in Spokane, Washington, and his name is Dennis Ottmar. And his cousin was actually Maurice Ottmar, who was one of the, I don't know, famous custom stock makers, custom rifle builders, kind of in the Al Beeson category, or as good or better. Quite a talented stock maker. Anyway, he bought one of my falling blocks I made, and then one day he come by with I think 4 bench rest rifles in the back of his Suburban, and he showed them to me, and I was like, I gotta have one, but of course I'm not going to buy one.
Right.
So then I got serious about building bench rest actions, and him and his buddy bought a first couple of the ones I made, and then one of the local guys, a guy by the name of Jerry Black. He's a very, I don't know what you want. He's a very fast talking, fast thinking, really inquisitive fella, local guy. And he was wanting to get into 1,000 yard. And so he was talking to Bruce Bear and all these guys around the country that, you know, there wasn't a lot of 1,000 yard stuff happening in the early 90s around here. And those guys are kind of the gurus at the time. And so Jerry talked me into building what became the Model L action, that 2-inch, 10-inch long, massive action. And that was probably the first action that really, what do you want to say? I had so many orders for them, which doesn't take much when you're building all the manual equipment, but I was like, man, how am I going to make all these things? And so in 95, I decided that it's time to incorporate and do this full time. So January 1 of 1996, I quit my tool making job and started building actions full time.
At what point did you go CNC?
1997, we bought the first CNC mill. In 98, we bought the first CNC lathe.
Okay.
So,
wow, you still
let me tell you what.
Go ahead.
Starving to death trying to make. I mean, you had the orders, but you just could not make stuff fast enough on manual equipment. And you gotta. And I'm not bragging, but at that point in my career, majority of my career was on manual equipment. I mean, I would say I was pretty fast machinist, and as a tool making, pretty creative with setups as far as efficiency, but there's just no replacement for CNC equipment as far as, being productive. And accuracy and repeatability and all that too.
Yeah. I mean, I can't believe you went over a year without CNC machines. Of course, this is, 90s, right?
We're talking 96.
Yeah, that's what I'm saying. So we're talking 96. I get it. But, my goodness.
I wasn't unfamiliar with CNC in the first, full-time tool making job I had. Daryl worked at the same company over on the coast. I spent 3 of those years programming and running a CNC mill. And then, one of the shops I worked at over here, he bought a CNC mill because I knew how to run them. And then another company I worked for, they were of course, again, we're talking late 80s, early 90s. The CNC was definitely used in tool making, but they tended to separate it out. You know what I mean? There was a couple guys, that's what they did. They did the CNC stuff, and then you had the tool makers on the bench using manual equipment. So I was working for a fairly large shop, and they kept us like, no, you don't get to touch CNC. Well, I happen to be on swing shift, so if there wasn't something set up and I needed to make some electrodes that were more than I could do on a cross-slide rotary table, I would go over and use the CNC program and do them over there.
Yeah. Why not? So you start bat in 96, bat machine?
Yep. Mm-hmm.
97, you get your CNC. Were you ever a bench rest shooter?
So I shot my first bench rest match in 1994 after I made my first
action.
Small action. Yeah. Tacoma Rifle and Revolver Club over in Tacoma, Washington. I managed to take second place at 100 yards, and then we went to 200 yards. And I had never shot at 200 yards. I'd never shot over wind flags at that point. I'm telling you what, I was like, give me my 22 Cheetah. I didn't know what to do with those wind flags. 100 yards, it was like, I don't know, the wind was low enough. I was able to shoot some real small groups and,
Well, they do it backwards, right? Because
anyway.
they shoot 100 yards in the morning when it's the most calm, and then they around lunchtime they shoot 200 when the mirage is up and the wind's blowing. Yeah.
Separates the men from the boys, right?
Yeah. In F class, we have PAMA. We shoot the PAMA course, which is 800, 900, 1,000. Well, you start at 800 in the morning, so just almost just hold center and pull the trigger, right? But after lunch, that's when you get to 1,000, and the field is pretty stacked all the way to 1,000, and then 1,000 is where everybody's feeling good, and all of a sudden 1,000 happens, the wind's up, the mirage is up, and it's pretty rough. So now you're full blown. Was this a one-man shop when you started?
Yeah. So one-man shop, and I hired my first employee about 6 months in, a guy by the name of Tom Dixon. He was a bench rest shooter that I had met over on the coast. He was actually from Lewiston, Idaho, just south of us, but he was retired. He'd taken early retirement from Potlatch Paper Mill. He was a millwright, but he did his own. Him and his buddy had a lathe, and they did their own barrel work and stock work. And but he wanted to learn more machining, and I didn't have any money, so it worked good for me. He wasn't wanting much money. So Tom worked for us until Daryl came to work for me. And so that was probably how many years did he work for me?
I started
12?
in 09. So.
Wow.
Yeah, so he worked for us for 13 years. And Tom was the best thing that ever happened to, I don't know if I would have had the success that we had because Tom didn't need to work. He was an avid bench rest shooter, a good bench rest shooter, and very well liked as far as he was super nice personality, just a big teddy bear of a guy. And he would always finish in top 20 at super shoot, nationals, whatever. I mean, he was a good shooter. And so, yeah, he traveled to all the big matches. And so people saw our stuff, and I wasn't able to travel as much. I usually make it to the super shoot from, I think, until probably about 2002. I made it to the super shoot most every year. Then I'd get a few 1,000-yard matches in, maybe one a year. But yeah, so Tom came to work in mid '96, and then I think I hired my next guy in 1999, who is still with us. And yeah, and so it goes.
Yeah, for sure.
For a while, you're buying a new machine every year.
Oh, trust me, I know all about that. So now Bat Machine's up and running. Now you're in the bench rest circle. How many iterations of your actions? Because you made the first one. What were some of the changes that you started making when you started realizing, things could be better? And is that part of your success? Maybe never being happy with the original design?
So the basic design has not really changed, but there's been a lot of, I don't want to say little tweaks,
updates
that continue to make it better. Fire control system, probably the major one that makes the biggest difference. The way we guide the firing pin now compared to how we used to do it. And as far as models and changing that kind of stuff, really, we just discontinued the L model. And the B model was the first short range bench rest action we made. Well, I made the S model was the first one actually, but it was a little too short for people. So the B model kind of became the most common, which then turned into the DS model, and that's after Dwight Scott. He had some input into that, some things he wanted tweaked. That was around 2002. I think we did the first overhaul of that model, and that was fire control system stuff. And then the M came about, M was fairly early on too, around 1998 probably. The first M came for a lighter weight action for the 17-pound class and 1,000-yard stuff. And you're probably that's probably the one used in F class the most, at least early on.
Pretty familiar with the M. The 3L. Why did you get rid of that action? It seems like that was a fan favorite.
We didn't like making it and didn't like it.
That's a good enough reason. Sales were not very good on it either. So the L's, the three lug models came about in about 2002 as well. Originally a short range one for short range bench rest, and then the longer one for 1,000-yard type stuff. The thing I don't like about the not having through raceways is the ability to straighten the bore after all the rest of the machining is done. So I custom built a special, I don't know what you want to call, line bore honing machine with some custom made diamond honing sets that I had made. And we used that for years to go in after all the machining's done and try and straighten the bore back up, get rid of I don't know. You're doing a lot of round stuff, so maybe that
doesn't maybe have as much internal distortion from machining ports in weird places. There's a lot of, it's not a lot, but when you're trying to make basically a perfect action, you get the steel collapses in the port area after you machine the port. The tang moves. So even though you're doing it all out of hard material, things still move. So we've always tried to straighten the bore up to be perfectly in alignment with the barrel tenon and square to the face. So that whole thing is axial aligned. And the 3-lug, the full diameter bolt actions make that very difficult to achieve.
I see.
And the final straw, the guys in the shop crashed some of the tooling. So,
and I said, I ain't making it again.
Well, that's a good enough reason to stop making it, I guess.
So the replacement. Oh, you tell me, why do you guys like the 3-lug?
I don't know. I've never owned one, but I just know that I have a few friends that they had the 3Ls, and now that kind of the Magnum car, everybody's going to Magnum. They were trying to get bolts from you, and you're like, nope, we're not even making that action anymore. And I've seen some guys online trying to, scoop up, hey, I want to buy some 3L
Older
actions. They want to buy, and I don't know.
Yeah.
I don't know the reasoning behind it. Maybe they just, I don't know. I mean, it seemed like the minute you quit making them, I started seeing a lot of posts of people wanting to buy them.
And we did make a big run of Magnum bolts for the 3-lug longs, and tried to support everybody that way after we stopped, told everybody we were going to stop making them. And I think we have one more run scheduled of a few that are still on order. But yes, it's the bodies themselves we don't plan to make. Like I say, we don't have the ability to make right now with the crash tooling.
Oh, we could make the tooling over. It's just,
but the bolt bodies are a possibility if we have enough orders. So
I see. Okay.
Yeah.
Well, there you go, guys. If you have a 3L or and you want a bolt, better get in on this right now before they change their minds.
Which could happen.
So kind of the replacement for the 3L is the Nuvo long version, and then we don't. It has the same issue as far as it's difficult to get a perfect bore out of it. So we're working on, we've made the aluminum version of that. And that is simpler because we can keep a straight bore, and any distortion that would occur while we're doing ports can be straightened out before we put in the steel insert. That's the aluminum receiver bodies have their own challenges, just because of the hard anodizing. That's been the thorn in our side since we started making those. We're still fighting it. Took a lot of experimenting to end up with maintain dimensions through after the hard anodizing.
It's for us, just any coating you put on these things, right? Because you have to compensate for that in the machining process. And then you have to, because there's a tolerance in the thickness of the material. So if you're trying to maintain a certain level of tolerance on your final product, then you have tolerance stacking, right? And how do you control tolerance stacking when that in itself is not a good thing, right? So we deal with that to some level.
If you're trying to hold tenths, and anything you do afterwards changes stuff.
Yeah, absolutely. So, all right. So I got some questions for you. So, the 3-lug, I don't understand why people like the 3-lug, to be honest with you, because it makes the bolt harder to open. Correct? I mean, because now you have less leverage.
You got to accomplish the same amount of firing pin cocking and 30 degrees less travel.
Yeah. So I myself don't like 3-lugs, but, some people do. uh, are your two lugs, if I was to go buy a current version, your latest and greatest two lug, is it going to be, because it's still the same mechanical requirement as far as, like you said, compressing the spring, right? You're trying to compress a spring 250 thousandths, for example. Yep. Have you made improvements over the years to make the cocking easier, or is that even a concern?
It's always a concern for bench rest shooters or anybody, really, even the PRS guys. There's only so much you can do with the design. I believe the current way we have it set up, with the firing pin being guided by the bore of the shroud and the firing pin body being nitrided, is probably the biggest improvement we made in cocking effort. The rollers help a little bit, and then experimenting with different spring rates is about the only other thing you can do. There's really, I mean, you have in the 90-degree throw two lug receivers, you only have so many degrees to make that travel happen. There's just not a lot you can do about it. You got friction of the thing moving backwards on the slot as it's coming back, so there's not really a lot you can do to friction's friction. I mean,
you need to make a one lug action,
surface finishes,
and then
one lug action,
and then you have about 200 degrees or so.
Well, I guess you could do like the odd shoots push-pull action.
Yeah, there you go. Now, you talk about spring weight, which is obviously, I mean, again, you lower the spring weight, you lower the cocking force or the bolt lift requirement. However, I want to make sure that our viewers don't hear this and go, "Oh, I'll just put an 18-pound spring in there," because there's also a certain level of required force to ignite primers, right?
Yep, certain level impact force, and that's really interesting too. That through the years, the experimenting that's been done with it. Back when I started making actions, silhouette shooting was still quite popular, and lock time was really talked about a lot. The time it takes from when you pull the trigger to when the firing pin hits the primer. And I get it that is important, especially when you're shooting freehand or whatever, offhand, whatever. You want to reduce that time as much as possible. But what you find in bench rest and extreme accuracy is that a slower firing pin fall with a heavier pin and a lighter spring actually produces better accuracy. And it's may seem counterintuitive, but I don't know how much you've experimented with it, Eric, but I know the top gunsmiths that we've worked with over the years, that's where they all end up at.
Yeah, I get, the typical self-tinker, the guys that like, kind of like we did, right? We got into it. I mean, you got into it way different than I did. But the point is, you start tinkering with your rifle, and if you have any kind of mechanical skills, you want to, at some point, you're going to start working on your rifles, right?
Messing with it, yeah.
And it seemed like the biggest thing everybody wants to do, it seemed like it was kind of a fad. I'm glad it's going away, but it was the fluted lightweight firing pins. Right. And again, it's going to increase lock time, but all of a sudden the mass was decreased. Right. So now they're trying to make up for it by just putting a heavier spring. And it seemed to every time somebody had an issue or they brought me a rifle, they said, man, this just thing that's, I've redone all these other things, and all of a sudden, it's just not working. And anytime I saw a fluted firing pin, I just throw that away and replace it. But
yeah, the one thing people don't understand too, when you think about the firing pin system, and it's a really important that part of the movement, that when that's happening is probably one of the most critical parts of the action, is that spring is also part of the moving mass. So you put a lighter spring in, you're also reducing the mass of the system. We have a mathematical formula in an Excel program that we play with sometimes, and I can't remember what the percentage is that the spring adds to the impact force just because of weight, but it's substantial. Now, I'm not talking spring force weight. I'm talking the physical weight of the spring moving as it's moving the pin.
Right. So, what would you recommend the lowest spring weight, that anybody
I'm not going to recommend one.
You're not. You're smart.
So one thing I would say is, if all of our shooters understood the importance or the difference in primers and loads, that people could shoot lighter springs, but we have to build stuff that'll work for everybody every time as much as possible, and therefore some of our spring weights are based on that rather than maybe what would be ideal for a certain primer.
All right, so can we at least give them a minimum? Like, hey, don't go below this.
So on a Model B, Model B DS 18.
Oh, wow, you went way lower than I thought you were going to do. I just tell people just don't go below 24 pounds and you'll be fine.
On a Model M, that's probably more closer with large rifle primers.
Yeah. Well, I'm used to all that. Yeah, 24 pounds. And I personally use 28 pounds on mine. Just I use a lot of, I use Russian primers, so they have pretty hard cups. So I like that 28 pound just to really ignite that.
And that's the thing, your primers require more, and some people don't understand the difference.
It makes a huge difference on your SD too, if you're getting enough impact on that primer to ignite it consistently.
Ignition is such a huge part of the action. I don't know if you know, but we make these bolt shrouds. This is just for a replacement for Remington 700, and it's a better Remington 700 bolt shroud. We kind of fixed all the issues with the Remington 700s. The boss is larger because the Remington 700, the standard, has about 20 thousandths of slop in there. We minimize that by, ours are, they're about 5, well, depending on the bolt, right? Because the bolts are all over the place. But, ours are much tighter fit. We increased the length of the boss as well to have more engagement. We relieve the center of the hole, the guiding hole. We relieve the center so that you only, the pin is riding in the front and the back, but not in the center, because you really don't need it. It's just an alignment deal. And of course, in the back, we clearance for the cocking piece, and also for the cocking piece on the slot. And I'm showing you a section portion, but on the slot for the cocking piece, we also relieve that wherever it's not touching, so that minimize drag force. And these shrouds, when we send them out with a Wolf 24-pound spring, so that when people replace them, I'm like, replace the spring, replace the shroud, clean everything up. And man, we've been getting some amazing feedback on these shrouds, simply because people have issues and they always want to go work. They always want to work on the load. It's the load. They always blame themselves. So they changing primers, powders, all kinds of things. And they never consider that it's the bolt shroud and the spring that's causing all these issues, when it's such a major part of it.
No, you're 100% exactly right. And that drag that happens in the shroud in the back end there is really important. And then the other part that's important is the inside, that the spring's not dragging on the body any more than it has absolutely necessary. Our pin touches the bore hole in the shroud, and probably touches a little bit in the square area. I mean, it's clearanced, but there's a little bit of rock there that it can touch, but theoretically should not touch. And then the other place it touches is the pin tip diameter. That's theoretically the only two places it touches in the bolt. The rest of it's all clearance.
Yeah, you just want to make sure it's lined up properly and just gets guided down the center. Now, you were talking about these so I guess rule of thumb is leave your actions alone. Don't go put a lightweight firing pin. Is that some of the, what are some of the common things that you find when a customer says, hey, your actions, I did this, I did that. What are some of the things that customers have done to them that actually thinking they were going to make them better that actually made them worse?
Too much lube.
Okay. Because lube itself can create drag.
That, and then the croil can turn to like a shellac and almost lock things up solid after it dries. That's probably the biggest thing I see is they think they got to grease everything or they oil everything, and the oil, it's fine if you clean it off regularly and reapply some oil. But like with our actions with the nitrided springs, and especially if it's a nitrided bolt and nitrided shroud, they really don't need any lube. Tiny, tiny bit of that TW25 we like to use, just very, very, very tiny amount. And they should be taken apart regularly and cleaned. The whole system, because it's amazing how many, and you probably see this yourself too, a lot of people will shoot cases that are have leaking primer pockets. And that little bit of gas ends up getting in the primer tip and into the bolt, and it starts gumming things up and slowing that firing pin travel down.
Well, they can also gas cut the firing pin, right? Which in turn pierces more primers. Now it starts, which in turn it just creates a chain reaction of just destruction.
Daryl spent all day yesterday helping somebody with that. Gas cut firing pin tip, and then realized it also gas cut the firing pin hole.
Ah.
And so the hole is bell mouth now. And so the primers, even though the load is definitely warm, primer's pretty flat, but they looked way worse than they should have. And so then take a loop and look at it, stick a pin in the hole, and it's like, oh yeah, there's a big old gap around 3/4 of the hole. So yeah, the only thing you can do at that point is new bolt or bush the firing pin hole.
So how does that happen?
Piercing primers. First time you pierce one, it's like a cutting torch.
All it takes is one?
It only takes one. And then it, like you said, once that pin tip gets torched, it tends to happen more often because the pin tip's not smooth anymore. And that's what we see anyway.
Now, what does that conversation sound like with a customer? I think we should cover this.
It's difficult. It's difficult because they don't. It's often they don't understand why they're piercing primers all of a sudden. They have, maybe they're working up a load and they pierce one, and then it's like they back the load off a little bit and they're still piercing them. And so they're a bit confused. And then it's a bit confusing to us too. Now, to add to that, it's not just hot loads. I had a situation last year with a customer that I ended up having to send me the complete rifle because I could not figure out what was going on. And I had him send me his dies and everything because he was piercing primers with relatively mild load. And then he started having case head separation issues. I'm like, okay, there is something majorly going on here.
He's having the full buffet of issues.
Yeah. Well, it turns out, and you're like, okay, so you're having case head separation. How much are you
Can I guess as to what was happening? So he was bumping the shoulders too much, which in turn every time I see a Pierce primer, I typically associate that with too much headspace because the case moved way forward, yet not enough that it still could ignite the primer, right? So it hits. Well, now the case gets a run at the primer, or the firing pin. And the firing pin, most people don't realize the firing pin is sticking out of the bolt. Go ahead and take your bolt out and decock it. That firing pin is sticking out. That's what it's like after you fire. So the firing pin's sticking out. The case ignites. It hammers home. Now the firing pin became a punch.
Yep.
Punches a hole through there. And now, of course, now you pierce the primer.
100% on track. Okay,
now,
so this is what the deal is.
The case head separation. Now, that we took care of the primer.
That started with just exactly what you said.
Well, now the case head separation, this gap that we just discussed, when the case when they fire the round, the case expands, it grips the case wall, but the back is unsupported.
Yep.
And that is what gets a free run of it stretches, right? And when it stretches, it thins it out, and you do that enough, it thins it out enough that it separates. That's what causes case head separations.
Yep. The situation Daryl was working with yesterday, we did, he had, I think, about 12 thou too, didn't he, Daryl?
Yeah. Well, yeah.
Because we added 8 thou to the bolt face, and then it still had a little bit of wiggle. But yeah, so this fellow that was having the case head separation, when he says thing to me, he was right. His die was set to where he was only bumping the case a couple thou, the shoulder. However, what he didn't notice was that his seating die was not reamed the full depth. It was a custom die. It was not reamed the full depth for the die to come down to the shell holder. So when he was seating his bullets, he was bumping the shoulder 30 thousandths.
My goodness. How do you not feel that? He's like, I got really heavy neck tension.
Well, let's say this. It was a 375 Chi-Tac, and of course he's using a big press. Yeah. My goodness. So, but yeah, you're 100% on track with the headspace issue. And it doesn't take 30 thousandths to pierce them. Like this fellow Daryl was working with yesterday, he had, I would say, between 12 and 8 thou excess headspace. And I'm not sure how his die ended up getting set that way. Part of it could have been measuring over primers that had a dimple when he was setting up his die.
Trying to use the same die for two guns that weren't chambered correctly.
Well, that's where you need one of our dies. There's the ad. Have you seen our dies?
I have seen them. I've never used one.
Well, I put a micrometer on because I don't. All my chambers are the same. However, as brass ages, it doesn't matter that I anneal it and all. You got to bump it. You got to
spring.
It's got more spring back.
Spring back changes.
So I hated that with my F-class rifles. I always had to verify it, and now having to deal with that 7/8 14 nut trying to move it at thou. It's
not a precise situation.
So I made a die and I put the bushing and the shoulder together, the neck and the shoulder, and then I just I put a cap with a micrometer, and then if you need a thousandths more bump, you just turn the cap down. So anyway,
nice, good idea.
That's what our dice are like, and it just, especially for the newer reloaders, because those are the ones that always have a hard time getting it set properly. So that's why I released the dies that we have, so that you bring the ram up, you bring the die to touch the show holder, lock it down, back off the ring to 10, and start sizing, and then just start turning the cap down until you get the desired bump. And you write down that setting, and if you have a different rifle, you follow the same process, and you may end up at a different setting, but at least it is so important that they get this right.
Yep.
It is extremely important. So I ran into a lot of people with the same issue that I finally decided, all right, I'm going to have to make a die, because that is a very common thing. Are you tired of trying to adjust your full length size and die for perfect shoulder bump? The Micro Headspace full length size and die resizes your brass cases to match your chamber, ensuring the best fit on every reload. The micro adjustable shoulder bump feature makes it easy to make perfect ammo that fits your chamber properly. Upgrade your reloading setup today.
Yeah, people don't realize it. Like you say, they'll argue with you all day long that they're not bumping their shoulders as much as, they're not creating their own problem. And it's, as customers never wrong, right? So you try and work with them, but sometimes they are wrong. And it's the thing that concerns me the most about this: familiarity breeds contempt, right? We get familiar with reloading, and it's like it's pretty basic process, but there's some pretty basic gotchas that we really need to always pay attention to.
A pretty simple question that I ask whenever they come to me and they have an issue, especially like when reloading, and I go, "Has it always been an issue?" They go, "No." Mm-hmm. I said, "Well, then you did it," because you know what I mean. And it's not it's not to put it to put it on them, but for me it's a pretty quick, easy to troubleshoot.
Yeah. What changed?
What changed? Has it always been an issue? No. Okay. So you did it, and it's okay, because most of the problems that I have in the reloading room, I create, right? That's the beautiful thing. We create them, but we can also fix them. I said, okay, now that we know that. So I had a guy one time, same thing, tell me, "Hey, my round, my cedar die, they had a Wilson type." He goes, the round always sticks in the die. And I go, "Well," I said, "it creates a vacuum sometimes, so you kind of just got to pop it out with your nail. Sometimes if the chamber and the sizing die and the cedar die are not all compatible with each other, sometimes the cedar die is too tight that it kind of gets caught at the bottom." He said, "That's not it."
Right.
And I said, he was saying that it was at the bullet, that it was getting stuck at the bullet. I go, "No, it doesn't get stuck at the bullet. Like the cedar stem doesn't stick the bullet." And he says, "Well, that's what's happening." I said, "Well, it's real simple. Throw a case in there without a bullet and see if it sticks." And he says, "It's stuck." I said, "Well, then it's not the bullet. Look somewhere else." You know what I mean?
Yeah.
And it turned out it was actually at the base. It was too tight. But we just have to. The first thing I do is I blame myself. It's like, okay, what am I doing? And the best thing to do is take it one step at a time, right? Take it out of the case, take it out of the gun, look at it, looks good. Okay. See if it'll go in the gun. It's most of the time it won't, right? And then it's size it. Are there any issues? Put it back in the gun. Did it work? If you sized, kind of like the guy you talk about with the cedar, I like to size my brass. I check it with a headspace gauge. I put in the gun, functions, and then I put a piece of tape in the back, and the bolt shooting closed. Now I know I'm good.
Yep.
And then I go to seat the bullet, and then I do the same test again. That would have saved that guy, because he would have known it's in the cedar portion, right?
So, yeah, right.
Which you would have never thought.
Yeah, right. You would, but you just can't take everything for granted.
Yeah, it's interesting.
No. And it's the same way in machining too. Like sometimes the guys in the shop will come to me with an issue. It's like, "Well, we're having this issue." It's like, "Well, I don't remember having that issue before. What did we change? Did we?" And then I'll find out, "Oh yeah, I decided to change this, so it's a little more efficient here," or whatever. And it's like, okay, well, but that also affects this. So, and it's when you have a proven process, you got to be careful about what you change, because it can affect more things than what you think it's going to change.
Not every change we make is a good one. I know that's the intention. That's the intended purpose, right? Is to make everything better, but sometimes it works the other way. So you talk about making actions and keeping the bore straight and all that. Have you noticed integral rails versus bolt-on, like the Picatinny rails? Is one better than the other?
As far as the receiver,
Yeah, as far as keeping things straighter.
definitely a round action with no more cuts in it than necessary. The receiver is going to stay straighter. However, the way we process the receiver basically eliminates that, because when the receiver is completely done, the final bore finish is done with the receiver screwed into a fixture that's perfectly vertical, and set seats on the receiver face, and then the bore is redusted so that there's any distortion that happened during machining is taken out. And we're not talking like a lot of distortion, but we're talking that maybe a thousandths of distortion in that bore. But we go back in and clean that up so it's perfectly square, and then we put it on a V block and spin the bore to the what do you want to say? It goes on a pin that fits the bore body, and then we spin it to the receiver threads and make sure that it's concentric.
I see.
So it really doesn't matter which model receiver it is. They all get that process, whether it's a round one or one that has an integral rail. But yes, the more machining you do on the outside, the more distortion that can happen. And it depends on lots of steel too. We find a big difference between lots of steel on the amount of distortion that happens and types of material.
What are your actions made out of, the stainless?
17.4,
Okay.
and the chromoly ones are 4140. Basic materials, but
All the bolts are chromoly, 4140.
4140.
For the gunsmiths out there, how much clearance do you recommend between the bolt nose and the counter bore and the barrel?
I think we set it up around 7 thou, 5 to 7.
Okay.
I think print says 7 plus or minus 3 or something.
Okay. Now, why 25-degree cones?
That is a leftover from sliding plate extractors.
There's laughing because I'm sure he's had this question before.
So the sliding plate extractor, it needs more clearance to snap over the case. In other words, you have a extractor sliding like this with a claw, and so it's coming from below the case rim to above the case rim. So the steeper the angle, the more that clearance has to be. And you're right, it's only 5 degrees. You're say versus 30. Is that what you're saying?
Yeah.
Eric?
Yep.
So back when I settled on 25, Allen Hall was 25. Kelby's was 30. And part of the big complaint about both Hall and Kelby actions at that time was lack of extraction cam. And of course, any clearance you have under the extractor reduces the amount of extraction cam available for, popping tight cases out of your receiver, which, I mean, back in the day, a lot more people shot what today I guess we call clickers, where every shot they're having to pop it loose with the bolt handle. But that's it's a bad practice. It doesn't do anything for you accuracy wise, and it really screws up your rhythm.
Yeah.
But back in the day, it was like, I don't know, it was a kind of just a fact of life to get the right node with the brass that was available.
Well, the clickers were a thing. Weren't the clickers a thing because people used to neck size?
Neck size only, yeah.
Yeah, they were only neck size, so that's where the clickers came from.
But when you're shooting, I mean, back when I started shooting bench rest, Lapua wasn't on the scene yet. So you were shooting the old 220 Russian brass, and then Norma came out with brass, which was soft as soft. None of the brass was the quality that we have today. We're really spoiled today in all calibers, in my opinion, with brass from Lapua to even the factory stuff. A lot of the, you know, Hornady brass, it's not bad, but it's soft, relatively speaking. But
so can we go to 30 degree?
You know, I guess from a backwards compatibility standpoint, I guess it wouldn't hurt the guys that have 25-degree cone chambered barrels.
That's what I do on
the
mine.
outside.
Make it 25 so I can swap it back and forth between the Nuvo and my Model B.
The Nuvo is 30 or is it 25 as well?
30.
It's 30.
Okay, yeah. All right, we're trending up. We're trending up.
Okay, we'll consider it.
So you know why the 30? Everybody wants it. Well, I don't know about everybody, but
so when you're threading, you can just use the
your compound's already set to 30 or 29 and a half, close enough.
29 and a half. Yep.
Yeah. So
but the 25 allows you to move the compound, make sure there's no coolant stuck under there so it doesn't get froze up. It's just we're helping you out.
I don't care if mine gets froze up. If all the cones are over 30, I don't care if it gets frozen up. It's never moving. So
just use a form tool.
That's what needs to happen. That's what happens with the bats, because I learned, I'd say this, I've said this many times. I've learned gunsmithing from Speedy, and Speedy's like, everything's broken, you check it, which means you don't even trust the scale on the thing. So I had to set up indicators and everything and do the trig so I could set it up exactly at 29.5 degrees, right? So it was a lot of just back and forth and making sure this thing was perfect. And then I locked it down. So my cross light is exactly 29.5. You know, verified with indicators and all. So every time I think about moving it, I'm like, you know, it takes me, I would probably get faster if I did it more often, but I remember doing it the first time and I'm like, I don't ever want to do this again. But anyway.
No, I'm the same way. No, I don't move my compound unless I absolutely have to, because for me, it's not, and I just ground up a form tool to cut the cone that sits in one of my Loris tool holders.
Yeah.
And the reason I don't like move my compound is because I have my tools on my manual lathes set up like a CNC. Every tool's numbered.
Yeah.
They have their own DO offset.
Yeah.
And you know, you walk up to the lathe, you may not be within tenths, but you're going to be within thousands.
Well, that's what I mean. You know, like I do the same thing. So the thought of me moving that, like I said, it might as well be frozen up. I'd be okay with it.
Mm-hmm. Yep.
Anyway, well, there you have it, guys. Someday, possibly not soon, someday you might see 30 degrees on every bat. No guarantees. How's that? Don't hold your breath. Okay. So on the bat MB, you guys specify a chamfer on the barrel there. If that chamfer is not done, the barrel won't seat all the way. You know what I'm talking about?
Yep.
So I just wanted to point that out for people that are gunsmiths, possibly new gunsmiths, that this is extremely important. Otherwise, you might have the barrel set up exactly perfect. Then when you go to thread it on, you'll have another possibly 25 thousandths of gap or so if they don't do that chamfer.
Well,
20,
not
whatever.
that much, because the insert, so it's bored to 1.270, the relief area, and the insert is a 16 thou radius insert. So theoretically, it shouldn't touch. There maybe would be 16 thou, 10 thou, maybe 5 thou interference there on a 1.250 blank.
Okay.
But
well, either way, they need it.
Yes.
They need a chamfer.
It needs a chamfer to make sure it touches.
Right.
That would be
base.
the same for the SB action as well. It's
okay.
recessed the same as the MB.
And neither of those are made anymore, but they're floating around there. So
yeah, just you know, those always follow the print. If I guess we need to maybe just specify that.
Yep.
Now,
especially when you're working with our 50 cal.
So you guys are getting to the big stuff. Oh my good, that thing's a massive action. Holy smokes! How much does that action weigh?
12 pounds.
Oh,
I think
massive.
it's 12 pounds.
Wow, that's impressive. I don't.
Just don't tell him about the one you've got there at the shop. He's working on something maybe bigger.
No.
That's not maybe bigger. It's definitely bigger.
The bigger's always better, right? And I am in Texas. Everything's bigger in Texas.
Yep.
Now, rimfire. Are you guys ever going to jump into? You talk about your first one was at 22. You ever going to make a rimfire action?
I don't know. Do you think we should?
I don't know. I'm actually, the reason I'm asking is I'm about to jump into the rimfire games. I built a PRS rifle, and I know they have F-class PRS. I was just consider. I don't know. I don't even know what's available. I think Stiller at some point made them. I don't know if they still do.
Yeah.
And of course, you have Voodoo now, and you have a few others, but that seems to be a pretty large market. Most of our, we make tuners. We sell a lot of tuners. I think that the rimfire is our biggest market because, they can't tune the load. So they just buy tuners from us, and they tune the loads with the barrel tuners. So it's a pretty large market, and it's growing.
So you asked earlier, this kind of alludes to where's BAT going? And if I'm not really intent on growing BAT into being a huge company, because a couple things, you lose touch with reality, which is, and our reality has always been extreme precision shooters, and you have to be responsive to them and be willing to do some experimentation on a regular basis, because there's some very talented gunsmiths and some very talented shooters, and sometimes they have legit feedback that needs to be incorporated. And so where BAT's going is basically continuing to refine our product and introduce new actions that we see need to be introduced, basically to reestablish the new top tier. And when we're talking about that, it's like that top level, we're being super picky about details because there's not a lot of room for improvement. But you keep trying. So with that in mind, adding a rimfire action and another large amount of manufacturing capacity, possibly to keep up with it, that will probably not happen anytime soon, just because we're fairly busy with, I shouldn't say fairly, we're always have a backlog. So, but we have made significant improvements in the last few years in the amount of output we've done without increasing personnel. It's mostly equipment that we've bought and tooling and procedures that we keep tweaking to make better parts more efficiently.
That's what I did when I started my machine shop. I was like, okay, I get a clean slate here. That was the beauty of it, right? Mm-hmm. So I started from day one. I thought, I need to buy machines that require the least amount of human input as possible. Mm-hmm. So that's why I bought, sub spindle machines that are, 4 axis and
yep,
all that, bar feeders, because that, one person can run 2 or 3 machines.
Yep. And so it's not only the efficiency in one person running multiple pieces of equipment, it's also the less a human being handles that part, the more precision that part can be, because people make mistakes. A machine can make mistakes, but it's usually the guy programming it or a chip or something like that getting into it. And so you can tweak the program, you can tweak the procedure in the machines. It's going to be the same time after time after time. And so you can eliminate that human error factor. And that's really important in trying to make repeatable tight tolerance parts.
Yeah, absolutely.
We've made a lot of improvements in that.
Yeah, we added 1,000 psi coolant. That was a big thing for us because you talk about the chips and things
a lot of
like
drilling.
Yeah, a lot of drilling, and we're doing with the dies. We make them out of 17.4. You talk about 17.4. That's what our dies are made out of. And
what are you running for coolant for reaming those?
Oh man, I couldn't
or is that
tell you.
proprietary?
No, what I did.
You running coolant or oil?
Yes, no coolant. But I went to my tool vendor and we kind of, and he says, well, this is what we recommend, and that's what we started running, and it's ran fine. So, but I couldn't tell you what it is because it's been a while.
And that's a resource that, having vendors that can make those kind of recommendations and get it right the first time is important.
Yeah. Because because it's not only knowledge, right? It's experience. I'm not their only customer. They have a lot of customers that are running very similar, 17.4. They say, well, they've had really good luck. Like they already went through the try and error. So that's why I go to them and I say, hey, this is what I'm doing. And they recommend a coolant, and it's ran great.
It's the same thing with cutting tools too. I mean, there's certain salesmen that come into your shop wanting to sell you tooling, and some of them are just salesmen. And then there's the guys that actually pay attention to what their customers are saying and what works and have really good recommendations. And when you find one of those tooling guys, you use him because it's incredible. If you looked at the same operation we do today to what we did even 5 years ago, just because of the improvements in cutter geometry and coatings and then programming techniques. I mean, it's not uncommon for us to take from a legacy program to change the amount of time it takes to cut the part in, from 3/4 of the time taken away.
You talk about the tool reps. We have a good one. He used to be a machinist, and he literally helped me tremendously when I got going. He, because he used to be a machinist. Some days he stay here until dark, just helping me, test these parts and run them. And he wanted to make sure I was up and running. And now we're pretty close friends. And he actually left that company he was with, and he went to go work for a competitor. And sometimes I'd call him anyway, and I go, hey, I know you don't work for this other company. And he says, and he would answer our questions and help us. Now he actually works for our tool sales. He's our tool salesman now. He doesn't represent just one brand, which has actually given him more flexibility. But it was such a benefit to have him. But also, you talk about tool recommendations. Because he started working for other brands, he got us in touch with a different, and I couldn't even tell you what brand of mill it is, but milling all the ports in our brakes. He says, hey, I want you to talk to this guy. He's we've had some good success with these tools. So we bought end mills from him, and the guy came out here and actually helped us set them up and run them. So, long story short, we were running those, I think we're running those end mills. It's a 1/4 inch end mill going into stainless, and we're running about 30 inches a minute and about 6,000 RPM, if I remember. And he brought the end mills, and we're getting about 70 parts per end mill. And he came and he says, no, man, you gotta crank it up. You're going too slow. I'm like, really? It seems like it's going pretty fast. Because the recommended, if we looked at speeds and feeds, the recommended was like 22 inches a minute. We're going to 30. He's like, no, go up. So we go up to, all I did, just crank the feed override. To 200, we like go to 150. He's like, no, go to 200. Well, now we're at 60 inches a minute. And that thing was actually sounding better. And he's like, no, you need to go up. Long story short, I think now we run those end mills, the new end mills, we run them at 100 inches a minute and like 10 or 12,000 RPM. And I mean, it's like, wah, it's so crazy, but it's so quiet. I made the just for effect, but it's not even that loud. It just plows in there. And the tool life is the same. but productivity went through the roof. I mean, these ports get milled, and I would have on my own would have never pushed it that hard, you know, because it's just crazy. But you know, once we got the 1,000 psi, that also increased our production. You know,
and your tool
people
life.
don't think of coolant as a tool, but it's one of the biggest tools we bought is those 1,000 psi pumps.
Yep. Yeah. So.
Yeah, drilling's also fun because now there was no more pecking. Just send it home.
Oh my goodness, isn't it scary hit and go on those drills first time though, with the coolant through and I just have to close my eyes sometimes the first time I run one of these newer drills with the coolant through and the high pressure coolant. It's just like there's no way this is gonna last. There's no way it's going to make it a quarter inch into the hole without exploding, but they do.
Yeah. And, you know, you're just thinking that inch is just going to shatter halfway through it, and then now you just got to buy a whole new body. But no, somehow they just, it's amazing. The technology that we have, I'm glad I'm a machinist now and not when you started.
Oh my goodness. We have it so easy. I mean, back in the day, well, tool makers are on a lathe, they're like pathetic. Most of them. And I had a tool maker try to tell me had to make some round cores one day, and he was trying to tell me I needed to be using high-speed steel. The carbide wouldn't work. Wow. This was back in the 80s.
Well, it's in the name. It's in the name.
High-speed steel, yeah. I mean, he truly believed it. He wasn't trying to yank my chain, but that's how. In end mills, I mean. We were still using high-speed end mills in the 80s. Carbide was protected like, we only use this when we're machining hardened H13. And, oh my goodness, things were so slow.
Yeah. I also went straight to shrink fit tool holders. Yeah. And my goodness, you know, we can run fast and efficiently. Tool life is great.
Yeah.
Everything's happy.
I still haven't tried shrink fit. I thought about it, but we went with a RegoFix system. Mm-hmm. I don't know if you're familiar with that. It's a shallow taper, like probably, I don't know if it's maybe even shallower than a Morse taper. And it, like shrink fit, it requires a special equipment to press the tools in and take them back out. And the reason I went with it is, well, you're using a lot of small tools too. At the time we switched to it, I wasn't confident that the shrink fit would maintain grip on 1/8" end mills. And so I decided just to go with this RegoFix system. And it works really well. I mean, super concentricity and whatever.
Yeah, as long as it works. But it's a great time to be a machinist to get into at least it was for me. Like I said, I went straight into 4-axis CNC machines with sub spindles. It took a while to figure out how to program it, especially being my first machine and going all in on that thing. 'Cause I'm like, if I crash it, I'm done. Like I'm literally done. Right. But, luckily I didn't. And, things are looking pretty good.
The other interesting thing is, we look at these machines and yes, they're not cheap, but when you look at the value of, and the productivity of the CNC equipment today, it's cheap. I remember in 1986, a advertisement for Fadal, just a standard 3-axis 21 station tool changer mill. And it was $100,000, and that was like breakthrough price.
Wow.
What can you buy today for $100,000 brand new machine? I mean, you can buy something that's way faster for less than $100,000.
Yeah, absolutely.
And so when you think about what the dollar is today compared to what is it in 1986, it's like that's pretty incredible.
It's
the
like
value we
$500,000 or
have
more
in machine tools. Yeah,
Yeah, and the tooling, right? Like you talk about carbide, it's relatively cheap.
It's cheap
for what the parts they do. Like I said, we're getting 70 parts out of a one end mill. And of course we rough and finish separately,
right. But you probably paid maybe $30. Maybe
that's about what they are.
Yeah, I mean, it seems expensive when you're buying a bunch of them, but it's
no, it's amazing. And like I said, the productivity boost that we got, because I think we're paying like $3-4 more than the previous ones, but the parts, we're getting the same amount of parts, but we're able to like go 100 inches a minute versus 30, so it's
right.
3 times as fast.
And the solid carbide end mills is where I've seen the biggest improvements. Like for a while it was insert end mills, like when you start getting above 5/8, maybe use the insert tool. But we found machining the hardened materials that the insert life, well, we started actually wiping out cutter bodies. The cutter bodies wouldn't take the heat. And if you tried to run coolant, the inserts wouldn't last. So we would have to like replace the cutter body pretty early. You know what I'm saying? You'd think that cutter body ought to last a couple of years, but if we didn't replace the cutter body every few months, we would be blowing up a cutter body just because they just fatigue and they'd lose, a pocket would go out of them. So then we went to solid carbide end mills, some of these new fancy variable flute whatevers, and yeah, they're expensive as heck. You're talking $200 or $300 for these large end mills, but we would get 100 parts at 4 times the speed.
Yeah,
as we were getting with an inserted tool. It's like
it's crazy.
And then the end mill wasn't actually wore out there. Then we take it over to the horizontal. That particular tool I'm thinking of, we were running in the Integrex, and then we take that tool and we run it in the horizontal as a rougher for another hundreds of parts before it was like the spindle load went up enough. Like, maybe we should replace it. It's like crazy.
Yeah, it's incredible. It's incredible.
So one item that we didn't touch on that Daryl wanted to make sure we get touched on was what.
Let me play that for you right quick. I actually have it here for you guys to see. All right, so this is Speedy was here. We did a live stream, and we're talking about this. Let me play it for you guys so that everybody can see what we're talking about.
The bad actions here, and it's nothing that's detrimental to the quality of Bat's work or workmanship. But what I've been seeing and been hearing from some of the customers I've got is that I've changed firing pin spring in my bat, and now it doesn't shoot at all, or it shoots very poorly, or shoots inconsistently. And they'll ask me if I can take a look at it. I'll take a look at it, and the first thing I do when I check, I want to make sure. Is this camera on up here?
Yes, sir.
I want to make sure that on your cocking piece, it's not bottoming out on the cocking notch down there. So I'll take a piece of business card. In this case, it's just a piece of index card, and I want to make sure that there's clearance underneath that. If there is, then it's something else in the firing control. But what I've been noticing, especially from the customers who change firing pin springs, I believe when they're tightening up the firing pin against the cocking piece here, that they're over tightening it, and what they're doing, they're causing a slight setback of the firing pin right here at the shoulder, because see, this one's not one of them. This one's the one that the customer dropped, but you'll see a little flange kind of take place right here, and when that does, it sets the firing pin further back into the cocking piece than it needs to be. And when that happens, it allows the firing pin to move further forward into the bolt itself. And now instead of stopping here on this boss right here, it's starting to stop here on the cocking piece. On the roller cocking pieces, it's a even worse situation because a lot of times, probably about, maybe 1 or 2 out of 5 that I've checked, they've actually cracked that cocking piece where that little pin goes through it. And I don't know why it cracks on the back and you don't see it unless you take it out. So I said, when you install these things, you want to tighten them up, but just tighten them up. Just enough that you're up against that shoulder, but not much more where you're causing that stuff to go back into that cocking piece a little bit deeper and cause that flange, which sets everything back, which allows this to move further forward. Okay. So that's one issue I'm starting to see a lot here. I said, I guess you and I are responsible for that, for talking about changing springs and keeping everything current.
That's what we're dealing with. So what causes that issue?
So we've increased the amount of travel of the firing pin. So the new bolts.
Move your hand over those, Daryl.
The new bolts.
There you go.
The notch is actually deeper than on an old bolt. So this is a new bolt with a new firing pin assembly. And so when the bolt notch was changed, so was the firing pin assembly to allow that extra travel. So when we bring this down, we have that little play. You can put a little bit of paper under there. But if I take this same firing pin assembly out of here and put it in this old bolt, then that will bottom out in this slot and won't have any play. So 2 options. If you want to have the extra travel, that can be milled down in the bolt. But what I normally recommend for most customers is to take your firing pin on the new ones, take the 2 set screws out, and then unscrew it about a 1/4 of a turn. And when you do that and you put it back in, then you'll have the play at the bottom. And if not, then go another, 8th, 16th, whatever it takes until you have a little play at the bottom on the. So that's the deal is the newer components in an older bolt causes it to bottom out.
Pretty simple, but yet I can see how that can get overlooked fairly easily.
Yep.
That was very informative, and like I said, I think it really helps our viewers to really kind of meet you guys and kind of get an insight as to the way you think and the way you approach things, and kind of your vision as to what a business should be and how it should be ran. And I think, at least for myself, I got a pretty clear vision that you guys are all about precision and doing things right. So, thank you.
We keep our best.
Yep. All right, guys. Thank you very much.
All right, thank you.
Keep them centered.
All right.
You too. Bye.